yesterday about you're concerned about drawing the solution curves accurately on the test. So I sent you an email saying that the sketches need not be accurate, it can be a rough sketch. So I won't ask you sketching the solution curves. You just need to draw the phase line and comment on the stability. So that's what is the email about. I didn't provide you the context. A few of me started asking, why did you send the email? So I just wanted to provide the context as well. So those are the three things. So before we start the lecture, do you have any questions for me?
Not a question, but the last time's lecture, it was vertical.
Thank you. Somebody told me that. Yeah, I'm not able to fix it. I cannot fix it. The only way out is you can download, I think, and then turn your screen accordingly. I hope it works. If it doesn't work, it is what it is. I'm sorry. Hopefully today I'm changing something and hopefully it will fix it. Otherwise, you will have one more lecture rotated at an angle 90 degrees. Okay, use your...
Lecture, it started horizontally.
I know. Yes, I don't know how to fix it, but let's see. You have done linear algebra. You can rotate it about 90 degrees and see it. I'm just kidding. I don't know how to fix. I think I'll be able to fix it today, but if I fix it, good for us. If I don't fix it, I'll fix it in lecture 3. Okay, that's all. I'm sorry. There are certain things I can't do it, so I can't do it. I don't know how to do it. Not I can't. I don't know how to do it. Okay, that's about it. So let's begin. Assuming that you have no more questions. In the previous lecture, we said that we are interested in solving first order differential equations to begin with. One of the methods is sketching the solution curves without actually solving it, number 1. Number 2 is using variable separable method. Number 3 is method of integrating factors. Number 4 is using Laplace transforms to solve them. Number 5 is using numerical methods to solve them. These are the 5 methods that we are going to use to solve the first order differential equations in this course. Now, in the previous class, what we did was we just did one thing, which is able to sketch the solutions curves approximately without really actually solving it. Okay. Now, in the process, what we did was, we discussed what is ordinary you already knew what is an ordinary derivative. So we said what is the differential equation, when is it linear, when is it non-linear, what is dependent variable, what is independent variable, when is it called autonomous, when is it called non-autonomous. And when it is autonomous first order differential equations, we try to sketch the solution curves by first finding the critical points, drawing the phase line after using the test point method, and then commenting on the stability, and then going on to sketch the solution curves. That's all we have done in the previous lecture. Is that clear? So we will continue from there on. So today what we're going to do is we're going to say, so every differential equation, you might have a solution or you might not have a solution. If it is a solution, the solution is going to be a function. The function is going to be continuous and one time differentiable. It will be differentiable one time because it is first order differential equation. If it is a second order differential equation, then the solution will be two times continuously differentiable. If it is third order differential equation, the solution will be 3 times continuously differentiable. But because we are dealing with first order differential equation, the solution will be 1 times continuously differentiable. Now, the solution can be in 2 forms. One is the explicit solution, meaning you're able to isolate y on one side. The solution will be in the explicit form. Sometimes the solution is in the implicit form. That means you're not able to really isolate y by itself. Okay, so what does it mean to be an explicit solution and implicit solution? We're going to look at that. So verify y equals e to the negative t over 2 is the explicit solution of this differential equation. So explicit, so this is a function, it is an exponentially decaying function. Exponential functions are continuous and differentiable infinitely many times, so it is one time differentiable as well. So here you are able to isolate y by itself, so it is an explicit solution. So you want to check, is it a solution or not? How do you check? You substitute it into the differential equation. If it reduces to an identity, then it is a solution. If it does not reduce to an identity, then it is not a solution, right? Do you agree with me on that? So you know that y equals e to the negative t over 2, and you find y prime is going to be e to the negative t over 2, and you're going to use the chain rule and differentiate the exponent, and then you're going to get negative 1/2. Now you're going to substitute y and y prime into the differential equation 2y prime plus y and check if it is equal to 0 or not. So that gives you 2 times negative 1/2 e to the negative t over 2 plus e to the negative t over 2. The question is it 0? So you will see that yes, it is equal to 0. Why? Because you get negative e to the negative t over 2 plus e to the negative t over 2 equals 0. So it is an identity. So it is a solution. It is continuous, it is differentiable, and you are able to isolate y by itself. Hence, it is an explicit solution of the first order differential equation. Is that clear? Very easy. It's something that I'm just saying it for the sake of completion. I'm pretty positive you all know it, you all understand it, but just for the sake of completion, we should see it once. Okay? So sometimes the solution is implicit as well. So what is an implicit solution? It is a solution of the differential equation, but you are not really able to isolate y by itself. So it is an implicit solution. So one such example is, okay, you have t cubed plus y cubed equals 1. It is an implicit function. Now the question is it an implicit equation? The question is, it is really a solution of the differential equation or not? So the way is, then how do we go about it? The way you go about it is, what did we do in the previous problem? You know what is y, you know what is y prime, you substitute it into the differential equation, right? So now you want to find y prime, but how do you find y prime for an implicit function? You use implicit differentiation. That's where you bring in your differential calculus. So what you do is you differentiate with respect to t on both sides. You get t cubed plus y cubed equals the derivative of 1 with respect to t. And the derivative of t cubed, now you're going to use the sum rule of differentiation on the left side. Derivative of t cubed is 3t squared. Y is the dependent variable. Y is a function of t. So when you differentiate y cubed, you're going to use the chain rule. When you use the chain rule, you get 3y squared y prime. And 1 is a constant, so the derivative of constant is 0. Okay?
Where do you get y prime?
Derivative of y cubed is using the chain rule. It is 3y squared y cubed. Okay, so you have a function y cubed here, y cubed. The outside function is to the 3, and the inside function is y. So when you find the derivative of y cubed, derivative of outside will give you 3y squared, and derivative of inside will give you y prime. Okay, not. Chain rule, right? F prime of g of x times g prime of x, something like that. So now you're going to isolate y by itself. So when you isolate y by itself, you get 3y squared y prime is negative 3t squared. So y prime is going to be negative t squared over y squared. So you see, now what I did was I started with the solution and I ended up with the differential equation. So this is how I can say that, conclude that. So t cubed plus y cubed equals 1 is an implicit solution of solution of the differential equation y prime equals negative t squared over y squared. So when it is explicit, you find y, you find y prime, plug it in, check whether it is an identity or not. When it is implicit, differentiate the solution, you should end up with the differential equation. So the strategy will be different depending on whether you get an implicit function or an explicit function. Okay? Good? Okay, so once you know that, now I want to tell you about initial value problem in a moment from now. But what is, okay, well, we are talking about ordinary differential equations. So it is an equation where you have ordinary derivatives. So I want to talk about what is how does a partial differential equation look like. It is, we are not discussing, this course does not deal with partial differential equation. I'm just giving you an example to give you a contrast. So here what happens is a partial differential equation has partial derivatives in it. Okay, partial differential equation is an equation with partial derivatives in it. What are partial derivatives? You have one dependent variable. So in this case it is u. You have two one dependent variable. In this example it is u, and you have two independent variables. In this particular example I have two of them, t and x. Okay, so if you have taken 2551 multivariable calculus already, or if you're taking it currently, you know that you can write this as partial u partial t is going to be 1/2 partial squared u partial x squared. Okay, so that's how the partial derivatives look like. You have just one dependent variable u, but you have multiple independent variables, in this case t and x. So partial derivatives inside the equation will give you partial differential equation, but this is not the goal of the course, so we are not going to discuss it. Again, for the sake of completion, I wanted to show you the contrast of ODE, so that's what is PDE. Okay, this is very useful one. I'm sure you will learn it. It's a heat equation. U is the amount of heat produced by an object or a body at a given time, at a given space, and at a given place of x. That's what is a one-dimensional heat equation. Or U can be the option tries, T is the time, X is the underlying stock. So this is the differential equation either governing the heat produced by the body or the option price at any given time for an underlying financial instrument. Okay, that's what it is. But it just like, I just want to, your textbook talks about it a little briefly, so I just wanted to introduce it as well. Okay, so now once we do that, remember our goal. We want to solve the first order differential equation using the graphical method, variable separable method, method of integrating factors, Laplace transforms, and numerical methods. You're done with the graphical methods. Now this is the first analytical method you're going to see today, which is a variable separable method. The name itself tells you the process, variable separable. Separate out the variables and find the solution. And if I believe correctly, people attribute it to Leibniz or Newton when they first wrote out the derivative. It is pretty much the origin of the differential equations as well. So I mean, when they first wrote out the integral, that's when the differential equations were born. So they attribute it to the Newton and Leibniz, if I'm right. Historically, if I'm right, that's what it is. Now, how are we going to do? I mean, typically in several textbooks, the variable separable differential equation would look like that. Okay, would look like that. Okay. Now, what is the what is the mathematical justification? If you look at m of t plus n of y times dy dt equals 0. So you can assume that let h1 of t is the antiderivative of the function, of the function m of t. M of t means it's a pure function of t. There are no y terms in it. N of y means it's a pure function of y. There are no t terms in it. Okay, so let h2 of y is the antiderivative of the function n of y. So if they are the antiderivatives, then m of t would be nothing but dh1 dt, and n of y is going to be dh2 dy. So you can write this differential equation as rewrite this as dh1 dt plus dh2 dy times dy dt equals 0. Now you can combine these two terms using the chain rule. H depends on y depends on t, so it's a chain rule. So you can write this as dh1 dt plus, dh2 dt, where h2 is a pure function of y equals 0. Now we are differentiating both terms with respect to t, so you can use the sum rule and say the sum of the derivative of the sum is equal to 0, okay? If the derivative is equal to 0, then the function itself should be a constant, so the solution of the variable separable problem will be h1t plus h2y is some arbitrary constant c. Now c is arbitrary, so c can take infinitely many values, so you will have infinitely many solutions as well. This is just a mathematical justification for the problem. I mean, you want to see some mathematical justifications. It's like, so that it completes your variable separable method. That's all. Okay? I'm not going to ask you. This is not for the test. Just for fun, okay? So that it gives you some complete picture. This is not for the test. I'm not going to really test you. I'm not going to ask you, give me the mathematical justification for variable separable method. I'm not going to do that. But, if you know it, you feel strong. So that's why that is there. Is that clear?
Is it a multiplication or is it a minus, like after dh2 dy?
After what?
dh1 dt plus.
Here?
Yeah.
Yeah, it's a multiplication. It's an application of chain rule. Okay. So this is one problem which I've given in the past on the quiz or the test. So I just typed it out. So if you want to, at your free time, maybe on a Friday evening, you can look at it and feel happy about it. Okay. Now let's look at this problem. dy dt equals negative. 3 minus 2t over y. Right. So this is. I mean, now you know it. Like, what is the order? 1. What is the dependent variable? Y. What is the independent variable? Good. Is it linear or non-linear? Non-linear. Why is it non-linear? Y is in the denominator and the exponent is negative. Is it autonomous or non-autonomous? Non-autonomous. Why is it non-autonomous? Because there is a t on the right side. Beautiful. Very good. So now the question is, first thing is you want to make sure that the y is not equal to 0, right? If the y is 0, then the derivative is undefined. Correct? Do you agree with me on that? So in other words, I mean, you can write it like, if you can write this as y times dy dt equals 3 minus 2t over y, not 3 minus 2t over y, you get 3 minus 2t. If your y equals 0, then the left side is 0. Do you agree with me on that? And if the left side is 0, then t equals just a 3/2. So that's not even a differential equation when y equals 0, right? That's that's so uncool, right? If it's not a differential equation, what's the point, right? So we want to make sure that y is not equal to 0 so that we still stay in the world of differential equations, right? So how do we go about solving it? Now you can, I'm going to, your textbooks, different textbooks do it different ways. There are two different ways they do it. I'm going to show you both ways, and I'm pretty positive you're going to pick one method, so I'm going to but anyway, just for the sake of completion, I'm going to show you both. So what are we going to do? We're going to say separate out dependent variables on one side, independent variables on the one side. So you write this as y dy is going to be 3 minus 2t dt, right? Do you agree with me on that? So you integrate both sides. Both sides. So when you integrate both sides, what do you get? You get y squared over 2 equals 3t minus t squared plus a constant c. Do you agree with me on that? Now, is there someone going to ask me, okay, don't you get a constant on the left side? Is there someone wanting to ask that question? Are we all good? Sure? Okay, so then that means that's all we get. So you integrate left side, you use the power rule, you get y squared over 2. And when you integrate right side, the integral of 3 is 3t, and the integral of 2t is t squared, and you get one arbitrary constant. I mean, you get plus c. Is that clear? So this is the first order differential equation, you get one arbitrary constant. If you're solving the second order differential equation, you get two arbitrary constants. If you're solving third order differential equation, you get three arbitrary constants. So the number of constants will always be dictated by the order of the differential equation. Keep that in mind. Now, how many possible values for C exist here? Infinitely, right? So C is an arbitrary constant. So there are infinitely many possibilities for C. So how many solutions do I have? Infinitely many solutions. Very good. Okay, you have infinitely many solutions, right? So you can also, some textbooks refer to it as family of solutions. Okay, that sounds really cool. So I'm writing it. Some other textbooks refer to it as one parameter family of solutions. Okay, so what is the one parameter they're talking about? C. One parameter is the C. Okay, so you have infinitely many solutions, so the textbooks or the literature refers to it as family of solutions, or one parameter family of solutions, and one parameter family of solutions is one parameter in this solution is a C. Now the question is it implicit or explicit? Is the solution implicit or explicit? Implicit. So remember when you when you solve the first order differential equation using the variable separable method, you would get, there will be times where you will get implicit solution, and it is okay to have an implicit solution. There is nothing wrong about it. Are you with me on that? Yeah. Why is it implicit? Because I'm not able to isolate, I did not isolate y by itself here. Now I can multiply both sides by 2 and I can apply the square root and then make it explicit, but I'm not doing all that. I'm leaving it as in a very nice form, elegant form. It is in terms of y squared over 2, and that's why it's an implicit solution. Clear? Are you all good? Are you comfortable? Is this the way you have seen it before? Okay. Now, some textbooks would refer to it, the same problem, this way. How do they refer to it? If you have dy dt equals, 3 minus 2t over y, then you would write this as y times dy by dt equals 3 minus 2t. Then you are going to integrate both sides with respect to t. Integrate both sides with respect to t, then you get integral y dy dt equals integral of 3 minus 2t dt. So this gives me y squared over 2 equals, integral of 3 is 3t, integral of 2t is t squared plus an arbitrary constant c. So what is the difference? Some textbooks, this is the actually correct way of writing it. Okay, that's correct way of writing it. Some textbooks write it like this. Now, or in other words, what they do is they write it like this, and they say integrating both sides with respect to t. They don't write the notation like this. They just write the solution like that. So what is the difference here? You see the way we wrote dy dt dt, and here we are just writing y dy and 3 minus 2t dt. So whichever you are comfortable, I will consider both the ways, and you can we will give you the points for that. So I just wanted to present you both the ways because different literature refers to different ways. Clear? Yes.
Why was this implicit again?
It is implicit again because I'm not isolating y by itself. I have my left side is in terms of y squared over 2. I'm not isolating y by itself, and that's why it's implicit. Okay? Now you should, yes, Roman.
Can you explain the main difference between the methods again?
Can I explain to you what?
The difference between the methods,
Here you're saying when you are integrating it, it is like saying integral of f prime of g of x times g prime of x dx is going to be f of g of x. That's what is the difference. I'm using the chain rule here. Okay, maybe I should not write it out like this. That's what. Here, your f prime of g of t is y, and your g prime of t is going to be dy dt. So you're going to write that. Clear? Or if you want an easier way to understand, it is like saying, okay, what is the derivative of y squared? It is 2y times dy dt. So what is the integral of y dy dt with respect to dt? That should be 1/2 of y squared plus c. So if you want to look at it, that's how it works. Clear? Okay. Okay, now, I mean, I got my solution to be y squared over 2 equals, 3 negative t squared plus 3t plus c. Do you agree? Now, you should be asking me the question now. What should be the question that you should be asking? Yes.
What does this mean?
What does it mean? Very good. So I would write this as y squared over 2, and I'm sure you're familiar with completing the square, right? Yes or no?
Yeah.
It's been a while, but you have done it, right? You have seen it in the past, right? So you write it as negative t squared minus 3t plus c. Then you write y squared over 2 is going to be negative. When you complete it, you're going to write 3t plus 9 over 4 minus 9 over 4 plus c. How did I get a square of 1/2 of the coefficient of the linear term? So I write this as y squared over 2 is going to be negative of t squared minus 3t plus 9 over 4. Now negative times negative is going to be positive, so you get positive 9 over 4 plus c. So I get y squared over 2 is going to be negative of t minus 3 over 2 squared plus c. So I want to bring these terms together, then that's going to be t minus 3 over 2 squared equals c. Now what does the graph of this look like? How the graph of this solution, what does it look like?
Sphere. Or
What is it? Oval, what is it called? Ellipse, right? It's not, is it circle? Why is it not circle? Because this is 2 here and this is divided by 1 here, so they are not like, that. It's an ellipse, right? And it's whose axis is? Major, semi-major axis is vertical, because it's along the y-axis, right? Do you agree with me on that? And centered at 0 and positive 3/2, right? So that's why when you graph it, and c is arbitrary constant. So for a different value of c, you get a different ellipse. So for several different values of c's, you get several different ellipses. Okay, I just graphed it using Mathematica. I got this. So for different values of c, you get different ellipses. So the solution, if you graph the solution, this is what you get.
So do you keep the
Just give me 1 minute. So for different values of c, C1, I get different ellipses, so I get infinitely many ellipses. Yes, Roman?
I was asking like on the previous, like, can you go back first? Yeah, on this, like, you're setting it equal to C1, so you're keeping it like...
Because c plus 9 over 4 is another constant C1.
Oh,
Okay? Now, will I ask you to graph? Again, this is just for fun. I just wanted you to understand, okay, now I had a first order differential equation. I recognize that it is a variable separable method. I found out the solution of the first order differential equation using variable separable method. I got an implicit solution, and I have infinitely many solutions, and the graphical representation of my solution is an ellipse whose semi-major axis is vertical, and it looks like that. Okay? All good? Okay, now here, so this is your ordinary differential equation. This is your initial value problem. So the ordinary differential equation plus the initial value problem will give you the, sorry, not initial value problem. This is the initial value. So ordinary differential equation plus the initial value will give you an initial value problem. An initial value problem. Okay, so when you have ordinary differential equation, you get an arbitrary constant c, and for first order you get one arbitrary constant and you have infinitely many solutions. But when you have an initial value problem, you use the initial value, and you find the value of c, you get exactly one solution. Is that clear? So ordinary differential equation plus the initial value will give you an initial value problem. Now I want to solve the initial value problem, but half my job is really done because I solved the ODE using variable separable method already. So I know the solution is y squared over 2 equals what is that? Equals negative, help me out with this, negative t squared plus 3t plus c. Is that right? Yes? So I want to use the initial value. How would I use the initial value? I'm saying substitute t equals 1, y equals negative 6, and find c. So when you do that, you're going to get 36 over 2 equals negative 1 plus 3 plus c. So that gives you whatever that gives you. 18 minus 2, c is 16. So substituting c is 16 back into your solution, you get y squared over 2 is going to be negative t squared plus 3t plus 16. Is that right? So that is the solution of the initial initial value problem. Okay? So do I have an arbitrary constant? No, not anymore. I have one initial value, so I use the initial value to find the value of c. So I do not have, do I have infinitely many solutions now? No, I have, how many solutions do I have? One, right? So if I don't have the initial value, I get infinitely many solutions. If I have the initial value, then I get only one solution. Are you with me on that? So what is the next question you're going to ask me, or what is the comment that you're going to make now? Yes?
Is it not still two solutions because it's y squared?
Okay, very nice point. Okay. Or is it just one ellipse?
Yeah, I guess it's one of it.
Then one, right? Okay, that's something that I didn't think of. So besides that, there should be one more question or one more comment. Yes?
I guess, I know like the type of stuff that we're dealing with right now. You said the initial value problem. And what we get is like a function that has exactly one solution. Can it, like, do the initial two and can there be more than one solution to the same problem?
No. For first order initial value problem, you will have only one solution.
Okay.
So what is the other thing that you want to ask or comment? How does the graph look like, right? Correct? Okay, how does the graph look like? That looks like that. Why is that? So you had the problem dy by dt is equal to 3 minus 2t over y, and you said y is not equal to 0. Do we agree did we agree on that? So when y is not equal to 0, that means, what does that mean? In my solution turned out to be, okay, if y squared over 2 equals negative t squared plus 3t plus 16, right? So, what is that I want to, so when y is not equal to 0, that means my solution would be either above the x-axis or below the x-axis. Y equals 0 is the x-axis, correct? So my solution would be either above the x-axis or below the x-axis, but not on the x-axis. Do you agree with me on that? Yes? So, but then, so the question is, where does it lie? Does it lie on the top or does it lie at the bottom? It lies on the bottom, clearly, because that's what is on a slide. But why does it lie on the bottom? Because my initial value is y of 1 equals negative 6, because that is below the initial value is below the x-axis, my solution will lie below the x-axis, right? The solution should be satisfying differential equation passing through the initial value, and the initial value is below the x-axis, and that's why my solution is below the x-axis and not above. So then you might have a question, why doesn't it jump? But the moment it jumps, it's not continuous anymore, but we want our solution to be continuous and one time differentiably continuous, so we don't want the solution to jump, so it just remains at the below the x-axis. Is that clear? And hence only you get the ellipse like this. Clear? I got it again, I graphed it using mathematical Wolfram alpha and I got it, but that's what it is. Again, I'm not going to ask you to sketch the graph. It's just that, you know, you get a complete picture now. So what did we see? We saw the first order nonlinear, non-autonomous differential equation. The variables, we were able to separate out the variables. So we used the variable separable method. We got an implicit solution. Without the initial value, you got one arbitrary constant because it's a first order. So you have infinitely many solutions. And luckily we were able to, will you be always able to graph it? No, but in this case we were able to graph it. We got an ellipse, so you got infinitely many ellipses. Then we introduce the initial value. Then we are saying, okay, my initial value is like this. Is that clear? Are you with me? Any questions? It, now you're picking me on my graph. So it's a rough sketch of the graph which I used it, and I zoomed it in so that you get, so it doesn't look like an ellipse, but otherwise it is, believe me, it is an ellipse because, you know, and it's not a circle because along the x-axis it's moving only 2 units at a time, but along the y-axis it's moving 10 units at a time. So that's why it's not a circle, so it has to be an ellipse. And why is it an ellipse? Because I mathematically proved it to you that this is the equation of the solution, so that's why it's an ellipse. Clear? All good? Okay. So now this is just another problem. I'm sure you will be able to figure it out. You know that the denominator cannot be 0, 1 plus y cube cannot be 0. In other words, y cube cannot be equal to -1. In other words, y cannot be equal to -1, right? If y equals -1, once again, there will be no differential equation, so we don't want that to happen. So we are talking about y not equal to -1. So now it's order is 1, dependent variable is y, independent variable is t. Now, is it linear or non-linear? Non-linear, autonomous or non-autonomous? Non-autonomous. Luckily for us, it is variable separable. So you would go 1 plus y cubed dy is going to be secant squared t dt. So you want to integrate both sides. So you would write this as 1 plus y cubed dy is going to be integral of secant squared t dt. So integral of 1 is just y itself, and integral of y cubed is y to the 4 over 4, and integral of secant squared t is tangent of t plus c, right? We recognize that tangent has asymptotes at pi over 2 and negative pi over 2, but I mean, you know, we don't want to get into those details, just leave it like that for now. Again, this is an implicit solution. And one more time, we are seeing that we are getting an implicit solution and you're getting infinitely many solutions. And this is a first order differential equation, so you're getting only one arbitrary constant, and the arbitrary constant is c. Clear? Easy, right? You will definitely see a problem on variable separable on the quiz, on the midterms, on the final. So, you know, one question down. How complex? That's a different story. We'll address it when we get there. Now, the next thing is linear differential equation. Okay, so now that you know one method, let's look at the other problem, okay? Let's say I have a problem like, ty prime plus 2y equals 4y squared, right? Now, how complex? You know, I posted my assessments in the Canvas, so you can look at it and you will know how complex it is. Okay. That's not a variable, it's known. Is that clear? Now that's a differential equation. Now let's do the drill. It's the first order. Dependent variable is y. Independent variable is t. Right? And it is non-autonomous. Agreed? Is it linear or non-linear? So yes, I mean in the previous lecture we said it should be in the form of y prime plus p of t times y equals q of t. Do you agree with me on that? That's what is linear. Do you remember that? Okay, so in that, which means we have to really isolate y prime and make the coefficient of y prime equals 1. Agreed? So let's do that first, okay? And then we can decide. So I want to divide by t, then I get y prime plus 2 over t times y is going to be 4. I got my problem wrong. Let me put it this. Oh, that's why you said nonlinear. I see now. Okay, good. Now, is this linear or nonlinear? This is linear. Okay, that's what I wanted to hear. I thought, why did you say that? Okay, now, by comparing this, the coefficient of y prime equals 1, right? So that's taken care of. The first thing is, okay, the coefficient of y prime equals 1. Then you know that p of t is going to be 2 over t and q of t is going to be 4t. So it fits into that type. So this is the first order linear differential equation. Is that clear? So now, can I solve this problem using graphical method? Just based on whatever I have done in the previous lecture. Can I solve it using the graphical method? No. Why? Because?
It's dependent.
No. Because in the previous lecture all my differential equations were autonomous and this is not autonomous, right? So I didn't teach you how to solve it using graphical method for non-autonomous differential equation. The method will be very similar, but it will be a little more complex. Okay, so can we solve it? Maybe, possibly, yes, but did I teach you? No. Okay. Now, is it variable separable? Can you separate out y terms on one side and t terms on the other side? Is it variable separable?
Yes.
No? Sure?
Yes.
Is it variable separable or not? How many say it is variable separable? Yes. Raise your hand. Okay, how many of you say it's no? Okay, so it's not variable separable. Why? Because I mean, you know, if you write it out like this, you write ty prime is going to be 4t squared minus 2y. And if you isolate y prime, it's going to be 4t squared minus 2y divided by t. You will never be able to bring out the y terms on one side and t terms on the other side. So it's not variable separable. So this is not variable separable. Okay, this is not variable separable. So what do? We want to be able to solve it, but it's not variable separable. So we need a new method. Thankfully, historians already invented it. So we are just going to learn that. Okay, clear? Now, how am I going to solve this problem? I'm going to introduce it just like the previous time. I'm going to give you mathematical justification and demonstrate the problem and possibly give you the graph. You know the drill now, right? So now, what they did was, the solution for this problem is that. Okay, so if someone is interested in the formula, see now a lot of people watch YouTube, so I don't know what you will end up watching and who will end up teaching what. So I just want to put out everything on the plate. So you know when you go there, you recognize what they are talking about. The solution for the first order linear differential equations is that. Now that's one way. I recommend don't memorize it. It's really sad. Okay, that's a sad day if you do it. Okay, now, but the question is, okay, then what is there a way out? There are, one way is you replicate the proof and find the solution. One is that. which is very intense and time taking. So not that. That method is possible, but don't take it. The second method is, the second way out is memorize the formula. Don't take it. Don't do that, please. You will make mistakes. I mean, in the past, people made mistakes and lost all the points. The third one is there any other way to really navigate? Is there a middle path? There is a middle path, and that is the middle path. Okay. Now, you see, I have not spoken anything at all. So now, how do we arrive at that middle path? That's the question that we have. Are you all with me on that? Okay. So we have a question in front of us. The question in front of us is that we want to be able to solve the first order linear differential equation. It is not variable separable. There are three options for us. One is you run through the proof, which is not, which is time taking. Number two is memorize the formula. Don't do that. Please don't do that. Don't do that. Number three is find a middle path. That's what I want you to do it. So I want to give you, if I said just use this and get away with it, yes, you will do it like a robot, like a machine, but what is it doesn't really fill the void. So what I'm going to do is I'm going to just briefly give you a mathematical justification for it. It's not a proof, but it's not a problem, somewhere in between. Again, this is not for the test. It is just for fun. On a Friday evening, you can just look at it and think about it, okay? I want to be able to solve y prime plus p of t times y equals q of t, right? Do you agree with me on that? But, let's make it simpler, okay? Let's make it simpler, when you want to make it simpler, you want to write it y prime plus p y equals q, right? So you want autonomous vehicles. First, you want to make a small one which goes on campus with carrying pizzas all over. So something like that, you want to make it simpler. So what are we doing? We are replacing the function p of t with a constant p, and we are replacing the function q of t with a constant q. Okay. Now, I believe, they came up with this problem. Let's assign two names to it. Maybe Euler and Newton, okay? They ran into this problem and they did not know how to solve it. So they got together one day and they said, okay, I came across this problem. Do you know how to solve it? Both of them looked at each other and they said, we don't know. Then they said, okay, is it variable? What do we know? We know only variable separable method, right? Is it variable separable? No, it's not variable separable. So they said, okay, let's do one thing. We know only variable separable, so let's make it variable separable. How do you make it variable separable? Let's keep q equals 0. Q equals 0, then it becomes y prime plus py equals 0. Then you get y prime equals negative py. Then you get dy by y equals negative p dt. Then you integrate, you get natural log of y is going to be negative pt plus k1. Then raise it to the e, and then you get k times e to the negative pt. Okay, so this is variable separable. This is easy. Okay, let's start from here. Are you with me on that? How many solutions do I have here? You know the drill. Tell me fast. How many solutions? Infinitely many. How many parameters? One parameter. What is the parameter? The parameter is k, right? Then they said, okay, let's complicate the problem now. And then they said, let's make q is not equal to 0. Okay. Then my problem is you get y prime plus py equals q. Then they said, okay, because my when my right side is 0, my solution is looking like this. So when my left side is not 0, maybe my solution might still look like that. That's what was their hunch. Okay, that's what was their guess. So they said, okay, let's start with something like denote yp as u1 of t times, u1 of t times e to the negative pt. So what did they do? They said k is a parameter. It keeps changing. So because it is changing anyway, let's make it as a function of time and rebrand it by saying u of t. Do you agree with me on that? See, this is just a mathematical definition. I'm just giving you a story very fast. Okay, so just so that you get an idea. Okay, just doing a problem is really boring. That's why. To make it interesting, I'm just telling you the story. Okay, so they said, okay, let's find out yp prime. Do we know how to find yp prime? Thankfully, someone invented product rule. So you just u prime e to the negative pt plus negative pu e to the negative pt, right? So that's using the product rule. That's what is the derivative. Correct? Then they said, let's substitute yp prime and yp back into the differential equation. So substitute yp prime in yp into the differential equation into y prime plus py equals q. So then that is going to be, okay, u prime e to the negative pt minus pu e to the negative pt plus p times u e to the negative pt equals q. Then these two terms gets cancelled out. So you get u prime e to the negative pt equals q. From here you get u prime is going to be q times e to the pt. So u is going to be integral of u prime with respect to dt. So that's going to be integral of q times e to the pt dt. Right? Do you agree with me on that? Yes? So I had a difficult problem. Be with me on the story. It's really nice. You know, historians did it for you. Okay, I'm not doing it for you. So this was a difficult problem, and they said, okay, let's make it easy by choosing p to be a number, q to be a number. They said, okay, it's still difficult. Okay, let's make the right side 0, and you get infinitely many solutions. Okay, because I'm getting infinitely many solutions because of k. Let's vary with time. So they replace k with u of t, and they're doing that, and they got u to be that. Right? So then what is my yp? Yp is u of t times e to the negative p of t. So e to the negative pt integral q times e to the pt dt. Right? Do you agree with me on that? So that's what is my particular solution. Do you agree with me on that? Now something they're going to pull something amazing. Okay, amazing for me. Hopefully it is amazing for you as well. So let's see what it is. It is, okay, then they wrote y is going to be k times e to the negative pt plus e to the negative pt times, q times e to the pt dt. So they are telling you y is going to be yc plus yp, okay? So that means this is a solution of, y prime plus py equals 0. This is a solution of y prime plus py equals q. Now, of course, if you substitute back, it will satisfy. But they said, what is the rationale? How can you guarantee that it satisfies? Then they said, okay, you know what? In 2024 fall, the students of 2552 in section C have done linear algebra before. And in that, they have studied that if you solve Ax equals 0, the homogeneous system of equations, you will get either a trivial solution or infinitely many solutions. And the infinitely many solutions is x equals v. But when they solve non-homogeneous system of equations, they get a solution like vt plus b. They must have studied in chapter 1, section 5. That is just a translation of the homogeneous solution. So this is the homogeneous solution. That's a translation. There is the justification. And so that's how they came up with this solution. Is this clear? You see why linear algebra is a prerequisite for differential equations? If I don't do this, you will think, why at all? Now, remember this. So this is, we simplified it. So then they said, okay, if you don't simplify it, your solution is that, right? Do you agree with me on that? Is that clear? But to run through the proof is difficult. To memorize the formula is difficult. So what is the way out? Your solution is k times e to the negative pt plus e to the negative pt integral q times e to the pt dt. So what are you going to do? The greatest common factor is the exponential term, which is never 0. So factor it out, pull it to the left hand side. So you get k plus integral q times e to the pt dt. So the solution is pretty similar, is equivalent to writing that. Right? Then differentiate it both sides with respect to t. So then you get y times e to the pt is going to be the derivative of the right hand side, which is k plus integral q times e to the integral pt dt. So this will remain, the left hand side will remain the same, e to the pt. In the right hand side, the derivative of constant is 0. So you would just get q e to the pt dt. Okay? So this is a justification. So this is, what is this? This is d by dt of the dependent variable times the integrating factor is going to be, sorry, there is no integral. the derivative of k is 0, the derivative of the integral will be is the function itself, because by the fundamental theorem of calculus, you will just get the function itself. So you would just get q times e to the pt. So this is going to be the q times the integrating factor, where this is integrating factor. And how do I get the integrating factor? Integrating factor is nothing but e to the integral p of t dt. So what I'm saying is, if you use the proof, it takes long time. It is very difficult to memorize the formula, but this, it is very difficult to memorize the solution, but the solution is almost equivalent to this. So I have established it for you. So you can, moving forward, whenever you see first order differential equations, use this. If someone asks you how did you get it, ask them to see you in your office hours, and you will explain it to them. Is that clear? Are you with me on that? I did not even introduce. This is all just for fun, not for the test. I'm not going to ask you on the test, but it's nice to know. Okay, now that being said, let's pick a problem. Okay, our problem is, ty prime plus 2y equals 4t squared, where my initial value is y1 equals 2. Clear? Are you all with me so far? Yes? No? That's sad. Okay, let me go back and summarize. So I have a first order linear differential equation. Either you memorize this formula or you memorize this equivalent condition. I'm saying memorize this equivalent condition, and I have shown you the rationale behind the equivalent condition. If you still have questions, go back and watch the video or see me in my office hours. That's all I said in the last 15 minutes. So how do you solve a problem like this? Step 1 is make the coefficient of y prime equals 1. Make the coefficient of y prime equals 1. So what would you do? You would divide by t, and that gives you y prime plus 2 of t times y equals 4t. Correct? The step 2 is to identify what is p of t and what is q of t. P of t is the coefficient of y, which is 2 over t, and q of t is the right hand side, which is 4t. Okay? Step 3 is to find integrating factor, which I would represent it by if, which is nothing but e to the integral p of t dt. So that's going to be e to the integral 2 over t dt. So that's going to be e to the 2 times natural log of t, which is going to be t squared. That's a step 3. This is what you will see on the test, on the quiz, on the test, on the final. So okay, that's step number 3. Okay? Step number 4 is you would write this the equivalent condition, which is the derivative of integrating factor times the dependent variable is the derivative equals q of t times the integrating factor. So which is nothing but d by dt of y times t squared equals 4t times t squared. So which is nothing but d by dt of y times t squared equals 4t cubed. Okay? Please make sure that I didn't make any mistakes, because I'm talking a lot and I'm prone to making mistakes at that time. Is this clear? So step number 5 is you are going to integrate both sides with respect to t. Then the integral of the derivative will give you the function back using the fundamental theorem of calculus. So yt squared and integral of 4t cubed dt.
Oh, okay.
So upon integrating the right side, so what do you get? You get t to the 4 plus a constant c. So isolate y, so then that gives you y is going to be t squared plus c over t squared, right? Yes.
Could you go through step 5 again, please?
Say that again.
Could you go through step 5 again, please?
Could I repeat the step 5 again? Integrating both sides with respect to t, what do I get? I get d by dt of yt squared dt equals integral of 4t cubed dt, and the derivative of integral is the function itself because of the fundamental theorem of calculus. They're opposite processes, they cancel out one another. So you just get yt squared on the left side and the t to the 4 on the right side. Yeah.
In the last line, can you write C1, or is the variable you have to do C over T squared?
In the last line, what did I do?
It's C over T squared. Are you allowed to write C1, or do you have to keep T squared there?
I have no idea what you're saying.
In the last line, you C over T.
This one,
Yeah.
are you allowed to leave it as yt squared?
No, you have C over T squared. Can you just write C1 because it's a constant?
Why is that?
At the end of the line, you have C
Here.
over T squared. Yeah.
Yeah, I don't have c over. Okay, I don't. Maybe something is not confusing. Okay, what I'm doing is I'm dividing by t squared. Why am I dividing by t squared? Because my t is not equal to 0. When I divide by t squared, I get y equals t squared plus c divided by t squared. I still didn't answer your question, did I? I did not. I'll answer your question after the class. I apologize, okay? Yes. You're talking too soft. Step number 4. Dependent variable. In the step 4, dv is the dependent variable. Yes.
I think what he meant was instead of writing c over t squared, why can't we just write it as c since c is a constant anyway?
See, t squared is not a constant. T is a variable. So you cannot reduce c over t squared to another constant. Does that make sense? See, when you write, what is t? T is the independent variable. It's a variable. So you cannot write it as a constant. You have to leave it like c over t squared. I still didn't answer your question. That was your question? Okay, good. Finally. Yes.
At the end of step 4, why do at the end, the start of step 5, why do you integrate both sides? Can you just derivate yt squared with respect to t?
My goal is to find y. I want to be able to isolate y. So when I want to isolate y, I want to get rid of the derivative. And the only way I can get rid of the derivative is integrating it. So that's why I'm integrating it. If you differentiate it at that point, you will use a product rule and you will get 2ty plus y prime t squared. Then I'm going back to the differential equation.
Makes sense.
Okay, any other questions? So that's how you do it on the test. Okay, this is again first order linear differential equation. You get one arbitrary constant c, you have infinitely many solutions. Now step 6 is I have an initial value. Step 6 is I have an initial value. Okay, recall my solution is t squared plus c over t squared. And my initial value was what? Y of 1 is 2, right? y of 1 is 2. So that means substitute t equals 1 in y equals 2. So that gives me 2 equals 1 plus c. So this gives you c equals 1. So my y is going to be t squared plus 1 over t squared. Is that right? Is that clear? Are you all okay with that? So if I ask you a problem like this on the test, you're going to run through these 6 steps and give me the solution. And that's it. So 2 questions down. Clear? So you are supposed to ask me a question now. What is it? What's the graph? How does the graph look like, right? So let's look at this. The differential equation, I'm done. So let's go to the next page, for your information, just for fun now, okay? So y prime plus 2 over t times y equals 4t. Then I get y of 1 equals 2. So if this is the case, so I said t cannot be equal to 0, right? Because if t is 0, then it's not a differential equation anymore. So t cannot be 0. So if I'm looking at it, this is my t-axis, that is my y-axis. T cannot be 0 means what? It cannot be the solution cannot be on the y-axis. It can be to the left side of the y-axis or the right side of the y-axis, but it cannot touch the y-axis. Do you agree with me on that? But my solution has to be continuous and differentiable and passing through the initial value, and my initial value is really at this point, okay, because it cannot touch the y-axis. So let's make it a dashed line. So just to show you that, okay, it cannot touch y-axis, but my solution has to be a continuous function passing through the initial value. So it is like, so if you graph it, you will see that the solution would pass like this. My graph is so bad. Like that. Okay? Now, can you look at the problem and draw the graph? No. I have sketched it before, and I have taught in the class at 8 o'clock right before you, so I know. So I'm not really asking you to sketch it, but that's how the graph looks like. You can see as t goes to 0, the solution becomes unbounded. As t goes to infinity, the solution becomes unbounded. It is a continuous function passing through your initial value, and because your initial value is lying, because the initial value is defined at 1, the solution will be to the right side of the vertical axis, not to the left side. That's all we need to take care of here. So where is the interval of existence? This is a new term that I'm using. Interval of existence. That means on what interval does your solution exist? It exists on 0 to infinity. It cannot touch 0. It cannot go less than 0. It has to be for all the values of t in 0 and infinity, the solution exists. That's all we are trying to say. Is this clear? Are you all with me on that? Clear? Yes. Could you repeat that again loudly? Can t be negative? Now, if my initial value was, let's say, suppose, now I'm just making it up. If my y prime 2 over t times y equals 4t, and let's say my y of negative 1 was 2, then I don't know, because I'm just saying, now my solution could be something like that. It will be on this side because, okay, this is guess. The graph is a guess. It's not accurate. Just to give you an idea, graph is a guess. Because my initial value is defined at negative 1, and negative 1 is to the left side, my graph will be on the left side, not on the right side. Okay? Are we all together on this? Now let's look at some complex problem. Let's increase the complexity a little bit. And let's make it easy. So, Let's rewrite this problem. This is not a problem. dy by dt plus y over t equals cosine t. And t is bigger than 0. Okay? So what am I going to do? I have 5 more minutes. Let's see if I finish it, good for me. If I don't finish it, it is an exercise for you. Okay, step 1 is make the coefficient of y prime, make the coefficient of y prime equals 1. Check, it's done. It's given in that form. So it's taken care of, right? Step 2 is you're going to identify what is p of t, and in this case it is 1 over t, and you're going to identify what is q of t. In this case, that is q of t is cosine t. Okay. Step 3 is you're going to write what is integrating factor. So that is e to the integral p of t dt. So that's going to be e to the integral 1 over t dt. So that's going to be e to the natural log of t, which is going to be t itself. Right? Bless you. Step 4 is you're going to write this as the derivative times the integrating factor, or dependent variable times the integrating factor is going to be q of t times the integrating factor. So which would mean I would write it as, I'm going to post the lecture notes, believe me, trust me on that. You don't need to write every single thing I write. It's like 100 years old, differential equations, okay? So you will write d by dt times t times y. I hope I'm right on that. T times y is going to be t times cosine of t, right? So that is step number 4. Step number 5 is you're going to integrate both sides with respect to t. So you write t times cosine t dt. So the derivative of integral is the function itself. So ty equals, how do you integrate that? Integration by parts, right? So if you now, I'm telling you, I'm giving you u substitution and integration by parts, guaranteed. Okay, there are such problems on worksheets. I'm doing one problem. I did a problem yesterday, u substitution problem and variable separable, and this is integration by part. So please know them. Okay. So I think you are going to say your u is that and your dv is that. Do you agree with me on that? So you're going to write t sine t minus integral of sine t dt. So this gives you ty is going to be t sine t. The integral of sine t is negative cosine t, so plus cosine t plus c. So you want to divide by t so that you can isolate y. So you got sine t plus cosine t over t plus c over t. And remember, anyway, t was bigger than 0, so it is never 0, so you're fine. But this is an explicit solution, right? Because I was able to isolate y by itself. So the point I want to make, the one point I want to make is, so when we solve variable separable problems, we got implicit solutions. When we solve the first order linear differential equations with method of integrating factors, in both the problems we got explicit solutions, right? It's not the norm, but it's the way it happened. But you would be able to do, both cases, any case might arrive at any place. Are you with me on that? Is that clear? You all good? Okay, so that's all I have for today. So when we come back, we'll learn about application.